urea, all the mostly the covalent compounds, they are non-electrolyte in nature. Now, electrolytes can further be grouped into two categories, strong electrolytes and weak electrolytes. Electrolytes which ionize completely means, as given in the example, the strong electrolyte hydrochloric acid on dissolution in water, it gets completely ionized into hydronium ion and chloride ion. Now, such electrolytes which ionize 100% or completely in their aqueous solution, they are termed as strong electrolytes. All the strong acids, the mineral acids, hydrochloric acid, sulfuric acid, nitric acid, and the bases like sodium hydroxide, potassium hydroxide, they are all strong electrolytes, their examples. And even the salts from these strong acids and strong bases, they are also strong electrolytes. On the other hand, a weak electrolyte is an electrolyte which is ionized to a small extent. Now, when we say that it is ionized to a small extent, it means there exists an equilibrium between the unionized electrolyte and the ionized ions, as represented here, the ionization of acetic acid, which is a weak acid, in water to give acetate ion and hydronium ion. Now, look at the Arrhenius theory of ionization, that whenever ionization takes place, Arrhenius proposed a theory that whenever an electrolyte is dissolved in water, it splits up into charged particles which are known as ions, and this process of splitting is known as ionization. The positively charged ions, they are called cations, and the negatively charged ions are known as anions. Another postulate is that the total charge on the cation must be equal to the total charge on the anion, so that the solution as a whole is neutral. Electrically, it should be neutral. The ions which are present in a solution, they constantly reunite to form molecules, and there exists a state of equilibrium between the ions and the unionized molecules, as represented over here. Ab is a weak electrolyte in the solid state. When it is dissolved in water, there exists an equilibrium between the aqueous A cations and B anions. Further, the properties of an electrolyte, they are the properties of its ions. At moderate concentration, in case of a weak electrolyte, only a fraction of the total amount of the electrolyte ionizes, and this fraction of the total number of molecules which ionizes on dissociation, this is called degree of ionization, which is represented by alpha. Now, alpha is equal to number of molecules dissociated to the total number of molecules taken. Now, higher the value of alpha means that large number of molecules, they are dissociated, it means the electrolyte will be stronger. So, we can compare the two weak electrolytes on the basis of alpha also. Higher the value of degree of ionization, more stronger is the you can say electrolyte. Now, what are the factors which influence the degree of ionization? These are the dilution. With increase in, as the amount of the solvent increases, the degree of ionization goes on increasing. This is known as Ostwald's dilution law also. Even at higher temperature, as we increase the temperature, degree of ionization also increases. Nature of the solutes, as I have already told you that strong electrolytes, they are ionized to a higher extent as compared to the weak electrolytes. So, the degree of ionization depends upon nature of solutes also. Degree of ionization is also dependent on the nature of the solvent. The solvents like water which have high dielectric constant, in that case the degree of ionization is more as compared to the non-polar solvents. In that case the degree of ionization is less. Now, degree of ionization is also affected by the presence of other substances in the solution. This is also known as common ion effect. Now, in this case, if we are suppose considering the ionization of acetic acid, and if we add sodium acetate into it, which has common ions, acetate ions with it, with the acetic acid, then the ionization of the acetic acid is suppressed. It means the the equilibrium shifts towards the backward reaction. Now, water is also a weak electrolyte, or it ionizes, it undergoes self ionization, which is represented by this equation. Two molecules of water, they ionize to give you hydronium ion and hydroxyl ion. Now, in this case, the equilibrium constant is represented as the product of the concentration of the products divided by the concentration of water raised to the power 2, because in this case 2 moles of water we are taking. So, this 2 is due to this. Now, we know that water is a weak electrolyte. It means the unionized water is present in a large concentration, and taking this to the other side, we get the expression that equilibrium constant K multiplied by concentration of water raised to the power 2, that will be equal to the product of the concentrations of hydronium and the hydroxyl ions. Now, we know that when water is present in a large amount, then its concentration is constant. Now, a constant multiplied by another constant gives us the constant represented by Kw, which is known as the ionic product or of water, that will be equal to the product of the concentration of the two ions, that is hydronium ion and the hydroxyl ion. Now, but we know that whenever water ionizes, the number of hydronium ion will always be equal to the number of hydroxyl ions. It means the concentration of hydronium ion, that will be equal to concentration of hydroxyl ion in neutral water. Now, if we replace one of these with the other, what do we get is, because we know that ionic product of water at 27 degrees Celsius, that is 1 into 10 raised to the power minus 14, then we can say that the molar concentration of hydroxyl ion or hydronium ion in water, neutral water, that is given by 1 into 10 raised to the power minus 7 moles per liter. Now, when we add an acid to the water, what happens? When we add acid, it means we are adding hydronium ion. Now, the product of concentration of hydronium ion and hydroxyl ion, that is a constant. It means when the number of or the concentration of hydronium ion increases in a system, then the concentration of the hydroxyl ions will be lesser. So, in case of an acidic solution, this concentration of hydronium ion is more as compared to the concentration of the hydroxyl ion. On the other hand, in case of basic solution, the concentration of hydronium ion is less as compared to the hydroxyl ion, because in that case we have added hydroxyl ions to the solution. Now, when the percentage of the hydroxyl ion or the concentration of the hydroxyl ions increases, correspondingly the concentration of the hydronium ion decreases. On the other hand, in case of neutral solution, as in case of pure water, the percentage or the concentration of hydronium and the hydroxyl ions, they are equal. Now, concentration of hydronium ion that can also be expressed in terms of pH scale. Now, this scale was introduced by the scientist Sorensen in 1909. What he suggested, he expressed the concentration of hydronium ions on a scale which is known as pH scale. Here pH is derived from a French word, potence de hydrogen, which means the potency or the percentage of hydrogen ion in the solution. Now, how can we define this pH? pH of any solution is defined as the negative logarithm of H ion or the hydronium ion concentration. So, on substituting the value of the percentage or the concentration of hydronium ion in the solution, we can calculate pH of the solution. In case of neutral water, when the concentration of hydronium ion is 1 into 10 raised to the power minus 7, then finding negative logarithm of 1 into 10 raised to the power minus 7 will give us the value of pH as 7. It means for neutral solution the value of pH is 7. For an acidic solution, we know that concentration of hydronium ion is more than the concentration of the hydroxyl ion, or the concentration of hydronium ion is greater than 10 raised to the power minus 7. So, the pH will be less than 7. They are inversely proportional. In the case of neutral solution, it will be equal to 7. On the other hand, for a basic solution, its pH will be more than 7. So, from 0 to 14, the pH can vary. At 7 it is neutral, less than 7 it is acidic, and more than 7 it is basic. Now, what is the effect of temperature on pH? We know that ionization increases with increase in temperature. Now, if the ionization increases, it means the Kw or the ionic product of water will increase. Now, as the ionic product increases, the concentration of hydronium ion will increase. Now, with increase in temperature, the pH value will decrease. The solution will become acidic. Now, what are the industrial applications of the pH? That is used in electroplating, corrosion, scale formation in boilers, nuclear reactors, preservation of food. In all these areas, pH plays an important role. For example, in case of electroplating, the shine of the deposited metal, longer life of the deposited metal, that depends on the pH of the medium. In case of certain industries which give wastewater which is acidic in nature and throw that water directly into the rivers or the canals, then that water which is higher in the HN concentration or is acidic, having low pH value, that is responsible for the corrosion of the bridges and decreases the long life of the bridges. Scale formation in boilers, that also increases as the pH of the solution increases. In alkaline medium, the scale formation is more, which decreases the life of the boiler. In case of nuclear reactors, the water is used as a coolant. So, in that case also the heat carrying capacity of the water, that is greatly affected by the pH. So, we have to adjust pH to nominal values, particular values, in order to have the maximum cooling power from water. In case of preservation of food also, the pH plays an important role. Now, Le-Chatelier principle is the effect of the changes on the equilibrium of a system. Now, if any system is subjected to a change at equilibrium, as stress is applied to the system, then the system shifts in such a direction so as to nullify the effect of this stress. Now, this is known as Le-Chatelier's principle, which was given by the scientist Le-Chatelier, that when a system at equilibrium is disturbed, the system adjusts in a way to reduce the change. Now, what are the different stresses? They are the change in the concentration of the reactants or the products, changes in the temperature, changes in the pressure. Now, if the reactant concentration of the reactants is increased, then the equilibrium will shift in the forward direction. On the other hand, if the concentration of the products increases, then the equilibrium will shift in the backward reaction. Similarly, changes in temperature that affects exothermic or endothermic reactions accordingly shift in a direction if they are subjected to a change in temperature. The change in pressure affects only the systems in which there are gaseous reactants or the gaseous products. So, this is all which we have in today's lecture. Thank you very much.